Assalamualaikum warahmatullahi wabarakatuh. We are from Group 5. We want to present the production of Maleic Anhydridre. So before I start, I want to introduce my group member. We have Nur Aziana binti Azhar, Nur Aisyah binti Ayub, Anis Nur Shazwani binti Azhar, and also we have Auni binti Jamali. So me as Anis Nur Shazwani binti Azhar, so I want to explain the introduction about the Maleic Anhydridre. Okay, Maleic Anhydridre is an organic compound which the formula is C2H2CO2. Maleic Anhydridre is one of the malic acid. It is colorless and or white solid. Maleic Anhydridre is produced by vapor phase oxidation of N-butane. Overall process have convert the methyl groups to carboxylate and dehydrogenation the backbone. It also conjugate double bond system. Due to traditional way, Maleic Anhydridre was produced by oxidation of benzene or other aromatic compounds. In both cases, benzene and butane are fed into a stream of hot air and the mixture is passed through a catalyst bed at high temperature. The ratio of air to hydrocarbon is controlled to prevent the mixture from igniting. Vanadium pentoxide and molybdenum trioxide are the catalysts used to the benzene rods, whereas the vanadium photophase is used for butane rods. In addition, in production of Maleic Anhydridre is have 4 atoms of carbon. Third of the original carbon atom is lost as CO2 when using benzene that have 6 atoms of carbon. The modern catalytic process start from a 4 atom of carbon and only attach oxygen and remove water. There are 4 steps of generation concept for production of Maleic Anhydridre, which is preparation of the initial mixture. Secondly, catalytic oxidation of the initial mixture with air, oxygen. And third, extraction of Maleic Anhydridre from reaction, mixture gases, and last but not least, purification and distillation of crude Maleic Anhydride. Thank you.
Physical and chemical properties: raw material, butane and oxygen; product, Maleic Anhydride; byproduct, carbon monoxide, carbon dioxide, and water.
Okay, this is our process flow diagram, which is describe the production of Maleic Anhydride from the reactant. Okay, so our input for this process are butane and air, which is butane and air will be mixed first in the mixture before being set in the back of the reactor. In the reactor, the butane will be react with oxygen. After exiting the reactor, it will be cooled down first by the exchanger before entering the absorber. The absorber will produce 2 output, which is water gas and Maleic Anhydride, but the Maleic Anhydride will enter the distillation columns to be purified. So the output of the distillation columns is Maleic Anhydride, which has been purified, and the others product from the distillation column will be recycled back to be used. Okay, next we move to the calculation. So the first calculation in a mass balance at the reactor. Okay, in this case, our production of Maleic Anhydride have 2 equations, which is the first one is when butane react with 3.5 of oxygen and it will produce Maleic Anhydride and 4H2O. And the second equation is when butane react with 5.5 of oxygen and it will produce 2 carbon dioxide, 2 carbon monoxide, and 5H2O. Mass balance at reactor. So at the beginning of the calculations, we assume the basis flow rate of butane is 100 kmol per hour, and then we factorize by divide by 1.9714, and then we get the value feed after reactor. As the stream is led to the reactor that contains of butane, oxygen, and nitrogen that produce carbon dioxide, carbon monoxide, water as evaporate, and our main product Maleic Anhydride. So From this table, I can show each substance of the stream, so we can see the balance from the inlet and outlet.
Assalamualaikum and hi everyone. My name is Nur Azana binti Azhar. Okay, I will continue this presentation about our mass balance of our plant, and we get a balance from the calculation from inlet that consists of stream 9 and stream 6, and for outlet contain stream 10, 13 and 15. So the calculation is in equal to out, so F9 plus FC equal to F10 plus F13 plus F14. So 107.25 plus 1445.65 equal to 1026.23 plus 4224.42 plus 507.25. Okay, next, this is about energy balance at reactor. We can see the number of mole, pressure and temperature. By using the formula molar enthalpy change, we can calculate each substance on each stream, and for inlet enthalpy we get 14290.18 kilojoule per mole, and the outlet enthalpy stream we get 3636A.06 kilojoule per mole. So for our heat formation have two as well, we have two equation. We use the energy balance of reactor is negative 2.19 multiplied 10 and the negative sign indicate the reaction is exothermic process.
Assalamualaikum warahmatullahi wabarakatuh. My name is Auni binti Jamali. Okay, I will present about process description. Okay, number 1 is separation and purification of maleic anhydride. The raw maleic anhydride has to be distilled after thermochemical processing. The resulting distilled maleic anhydride is then being crystallized by spreading of molten maleic anhydride. Okay, number 2 is reactor selection. Fixed bed reactor effective at high temperature. Conversion rate per weight of catalyzed is high. There are more contact between reactant and catalyzed than in other type of reactors. Okay, number 3 is byproduct of the process. First, carbon monoxide. Second, carbon dioxide. Third, water. Fourth, reaction takes place in 5, gas phase. Okay, for the last is catalyzed. First, vanadium pentoxide, molybdenum trioxide and sodium oxide is larger most widely used catalytes. Okay, number 2 is mixture of vanadium pentoxide plus molybdenum trioxide is the best catalyst for the oxidation of benzene. Okay, the next is conclusion. Maleic anhydride is produced through an oxidation process of N-butane. The waste product of the plant are carbon dioxide gas and water. The profitability analysis, it was concluded that the production of maleic anhydride using the process conditions simulated is very feasible. Exposure to maleic anhydride may occur from accidental release to the environment or in workplace where it is produced or used. Acute inhalation exposure of humans to maleic anhydride has been observed to cause irritation of the respiratory tract and eye irritation. According to information in IUCLID, maleic anhydride has not been found in the environment. The substance will hydrolyze with moisture in air or soil. No data have been found on human exposure via the environment. Humans may be exposed occupationally. Chronic exposure to maleic anhydride has been observed to cause chronic bronchitis, asthma-like attacks, and upper respiratory tract and eye irritation in workers. In some people, allergies have developed so that lower concentration can no longer be tolerated. Kidney effects were observed in rats chronically exposed to maleic anhydride via gavage. That's all from me. Thank you.